This is the F321 formal test that we did in February, just before half term. So question number 1. This question is about bromine and its compound. Bromine has two naturally occurring isotopes which have relative isotopic masses of 79 and 81. Both bromine isotopes are used in nuclear medicine. We've had the term relative isotopic mass, and that's for 2 marks. Now I've already wrote this in, so you need to put mass of an isotope compared to 112 and the mass of carbon-12 for the next mark. So you need to put both this and this, get those full 2 marks. Now most people got this right, so it's good that people are learning those definitions now. So next one. Complete the table to show the number of subatomic particles in an atom of bromine 79 and in an atom of bromine 81. So it's giving you a table, it wants you to fill in the protons, neutrons, and you've already got the electrons, and this is worth 1 mark. So there's no ions here at all. It doesn't mention ions, and it doesn't show you any ions. So the number of electrons have got to equal those number of protons. So we should have 35 and 35. Should have 35 and 35. So to work out the number of neutrons, we do this number here, the isotope number 79, take 35, and that gives us 44 for the top one, and for the next one here, 81 take 35, that gives us 46. You need to get all this correct to get that 1 mark. So B, this is one that people found quite tricky. So in the 19th and early 20th century, compounds containing bromide ions, Br-, such as potassium bromide, were used as sedatives and headache remedies. The recommended prescribed amount of bromide ions was 70 micrograms, and it gives you a conversion factor from micrograms into grams. Calculate the mass of potassium bromide in micrograms that would be needed to supply the recommended amount of bromide ions. And the next really important piece of information is to give your answer to 3 significant figures. A lot of people miss this out. 3 significant figures here. Okay. So, we want the answer to 3 significant figures. Top piece of information is irrelevant. This piece of information is important. This is, and this here. All the rest of it is irrelevant. These long answer questions sometimes put people off. But if you've got a maths, you can calculate moles. Yeah, it's giving you the conversion factor here. So 1 microgram is 1 times 10 to the minus 6 grams. So you must have 70 times 10 to the minus 6 grams of bromide. Okay. So how do we calculate moles? We use number of moles equals mass over mR. The mR of bromide is 79.9. That should give us a moles of 8.76 times 10 to the minus 7. But it wants a mass of potassium bromide. Now we just assume it's a 1-to-1 ratio. It is a 1-to-1 ratio. So we should have 8.76 times 10 to the minus 7 moles of potassium bromide. Now again, we just need that MR, so we just do 8.76 times 10 to the minus 7 moles of potassium bromide times the MR, which is 119. We get that from 79.9, and what was it? Potassium is 39.1. Okay, and your answer is around about 104. 4 times 10 times 4. What you need to do, put 104 micrograms to get the 2 marks. And where do you get the marks from? Get the mark for that, and you get the mark for this here. 2 marks. Now remember, if you've got a mass, calculate a number of moles, because even if you've got the conversion factor wrong, you get this answer right here. You just lose a mark at the end. So question C, part 1. When chlorine gas is bubbled through aqueous potassium iodide, a reaction takes place. Write the ionic equation for this reaction. So the clue in the question is chlorine and iodide. So the first thing you need to write is chlorine, Roche formula of that is Cl2, and iodide, remember I minus, halide minus, okay? This is an example of a displacement reaction, okay? Chlorine is more electronegative than iodide, so it will displace it. So we get Cl minus and I2. Okay, so what we now need to do is balance this out. 2Cl minus, we've got 2 Cl2s over here. I minus, we've got I2, so need a big 2 there. A lot of people got the equation right, but we've got to balance it. You need to make sure it's balanced for that 1 mark. In this case, it wasn't important about state symbols. Okay. Part D. At room temperature, chlorine is a gas and bromine is a liquid. When heated together, chlorine reacts with bromine to form bromine monochloride. BrCl has a higher boiling point than Cl2. Explain in terms of intermolecular forces present why BrCl has a higher boiling point than Cl2. In your answer, you should use appropriate technical terms spelled correctly. So, what I always do is go for the simplest thing first. Cl2, intermolecular forces in Cl2, because remember if we have Cl2, both the same electronegativity, so those electrons are shared exactly the same, so it can't be a polar molecule. It can't be polar. Also, it's not containing hydrogen, nitrogen, oxygen, or fluorine, so it can't have hydrogen bonding. So the only option left is van der Waals. So Cl2 has van der Waals forces. Make sure you spell these correctly, okay? So the other option is, now we've got H bonds, sorry, van der Waals, and also permanent dipole. So here we've got BrCl. Cl is more electronegative than bromine, okay? It's higher up in that periodic table, so Cl is going to hold these electrons more closely, so you're going to have delta minus, delta plus. You've got a permanent dipole across this bond that has permanent dipoles. I have to excuse the writing in this pen. So a permanent dipoles. Writing those two statements will get you 1 mark. So what you have to now do is say, what does this have an effect on boiling point? And BrCl requires more energy to overcome the intermolecular forces. Okay, you get a mark for saying that and a mark for saying that in this case. But you could also say that both had van der Waals forces. There's another alternative mark scheme for this question, so you can say that both have van der Waals. However, BrCl has more electrons. So if it's got more electrons, it's got stronger. So it has stronger van der Waals forces. Okay, if it's got more, if it's got stronger van der Waals forces, more energy required to overcome the forces. And again, you get a mark for saying that and a mark for saying that. There's two different alternatives here that you can use. I would always go for the permanent dipoles, but it doesn't matter because you still get the mark for saying that the full path antifiles forces. But the key point is here, saying that BRCl has more electrons, so stronger antifiles forces. If you didn't say that, you wouldn't have got those marks. Okay, and that's the end of question number 1. So question number 2. Magnesium chloride, MgCl2, could be made by different reactions. Step 1. The student added an excess of solid magnesium compound X to dilute hydrochloric acid. The mixture fizzed after solid reacted. Step 2. The student filtered the mixture to give an aqueous solution of magnesium chloride. Step 3. On evaporation, colored crystals of hydrated magnesium chloride were formed. Describe the chemical test that a student could have carried out to prove that the filtrate contains aqueous chloride ions. So if you'd all been reading your F321 exam techniques booklet, this should have been a nice easy question for you. So a chemical test that confirms the presence of these chloride ions. So that is, we just add silver nitrate, and then it's 2 marks. This is where people now drop the mark. So people did this but didn't state what you would see. If you got 2 marks, you need to put 2 points. And the next point would you would see a white precipitate, the second mark. Okay, you'd have to state an observation and also what you would add to get those full 2 marks down here. So B. State a second reagent that student could add to confirm the presence of the chloride ion. So remember, once we've got this white precipitate, we can add ammonia, okay, to dissolve that precipitate up. But you need to state the concentration, so you needed to put dilute ammonia. If you didn't put dilute ammonia, near enough everyone put this, but if you didn't put dilute, you wouldn't get that mark. And it's aqueous. So part C. Friend of the student suggested that solid X was magnesium oxide. Suggest one reason why the student friend was incorrect and suggest a possible identity of solid X. Reason is that magnesium oxide wouldn't fix. Okay, so magnesium oxide wouldn't be fizzing. Okay, so you needed to put magnesium oxide would not fizz, or something along those lines, or fizzing was observed. Yes, something along these lines, and suggest a possibility for the identity of solid X. We should all know that if we add an acid to something and it fizzes, it's got to be carbonate. Yeah. So you get a mark for saying that and a mark for saying that, 2 marks. So D. Hydrated magnesium chloride has a molar mass of 264.4 grams per mole. What is meant by the term hydrated? So all you need to put for this was contains water. So hydrated contains water. Just think of it to the opposite of dehydrated. Dehydrated means lack of water, so hydrated must mean contains water for a mark. And as soon as they start talking about water, you know they're going to ask you to determine the formula. Okay, so to determine the formula of the hydrated magnesium chloride, you must show your. So looking at the formula, and states here you've got to show your working. So you could have got the answer right, but if you didn't show how you got there, you won't got the marks. Okay, so here it gives you the molar mass of 264.4. You need to work out the molar mass of magnesium chloride. Magnesium is 24.3 and Cl is 35.5 times 2. You need to add them up, and that gives you 95.3. Okay, so 95.3. So 264.4, first of all, take 95.3 because that gives you the MR. Remember, it gives you the MR of the water. Okay, it gives you the MR of the water. So 264.4 take away 95.3. By my calculator, that gives us 169.1. And that's a molar mass of all the water molecules together. You need to find out how many they are. MR water is 18. So remember, oxygen is 16, hydrogen is 1. We've got 2 of them, so 18. So divided by 18, my calculator says 9.394 per Kelvin. So the formula has got to be 9x. It's 9. It's got to be MgCl2 9H2O. You need to put for your 2 marks. So question 2, part E. Magnesium chloride can also be formed by directly reacting magnesium with chlorine gas. Draw a dot and cross diagram to show the bonding in magnesium chloride, show the outer shell electrons only. So remember, if you look at the electronegativity difference between magnesium chloride, there are 2 extremes, they're both on the opposite ends of the periodic table. So it's got to be not metallic bonding, sorry, ionic bonding, okay? Ionic bonding. And we know that we've got 1 magnesium for every 2 chlorines. Yeah, 1 magnesium to every 2 chlorines. So magnesium is in group 2. It's got to be losing 2 electrons, so it's got to have a 2 plus charge, and it only wants to see those outer shells only. So it's just lost those 2 electrons. There's no electrons there, so that's fine. And then we have to show those 2 electrons on both of those chlorines. It's going to give 1 to that chlorine and 1 to that one. Because these have gained an electron, now these are going to be minus. Don't forget these charges, and then you need to show the rest of the electrons. So we're going to use crosses for the rest of the electrons. In chlorine, group 7 has 7 electrons in its outer shell. Okay, and that's all you need to put for that one. You get a mark for that and a mark for them. Nice easy 2 marks there. So F. The student decided to prepare strontium bromide SrBr2 by directly reacting strontium with bromine gas. The student was unsure whether this preparation would be more reactive or less reactive than the preparation for magnesium chloride in E. Explain why the student was unsure of the relative reactivity of the 2 preparations. So for this, you just need to look at your periodic table. And all you need to say is that strontium is more reactive than magnesium. So remember, these are group 2, and as you go down group 2, they get more reactive. Yeah, because they need less ionization. As they go down group 2, they get more reactive. And then they're comparing bromine and chlorine. So as we go down group 7, they get less reactive. Okay, so you need to say bromine is less reactive than chlorine. Okay, and that's all you needed to say for 2 marks. And that's the end of question number 2. Question number 3. The modern periodic table is arranged into blocks of elements based on their electron configuration. Part A. We now know that the electrons are in shells. Shells have subshells and subshells have orbitals. Explain what is meant by the term orbital. Now, I already wrote this definition in for you. and it's a region that can hold up to 2 electrons with opposite spins. Now, most people got a region that can hold up to 2 electrons, but you need to state with opposite spins to get that 1 mark. To get these definitions learned, use that F321 exam technique booklet. Really useful, that. So complete the electron configuration below in terms of subshells for an atom of phosphorus. Now, if you look at your periodic table, phosphorus has got how many electrons? 15 electrons. Yep, 15 electrons. So 1s2, 2s2, 2p6, that gives us 10, 3s2, 3p3. So 6, 7, 8, 9, 10, 15. That's your electron configuration for phosphorus for a mark. How many full orbitals are in an atom of phosphorus? Now, most people got this right, which is really, really good. But just remember to draw out your orbitals. So your 1s2, 2s2. Remember the next one's got 3, 6, 2, and then the next one 3 again. 1, 2, 3. So 1, 2, 3, 4, 5, 6. The 6 full orbitals. So 1, 2, 3, 4, 5, 6. These aren't full. You've only got 1 electron. So your answer for this is 6. Any question like this, just take 2 seconds to draw something out like this and just count up which ones are full. Remember, they don't like being near each other, these electrons, so they don't fill up straight away. And that is how you need to put for 1 mark. So question B. 1 mole of phosphorus atoms has a mass of 31 grams. What is meant by 1 mole of substance? So this is just a definition now. I've just wrote it in here. The amount of substance that contains as many particles as there are carbon atoms in 12 grams of carbon. Now that's definition, but you notice how I put in bold atoms. You needed to have atoms in there of carbon atoms. If you didn't have that, you won't get the mark. Okay? So C. Define the term first ionisation energy, and for 3 marks, this nice easy 3 marks. The energy required to remove 1 electron from 1 mole of gaseous atoms to form 1 mole of gaseous ions, and that's all you need to write there for your 3 marks. So question 3 part D. The first ionisation energies in atomic radii are chlorine, argon and potassium are shown below. Explain why there is an increase in the first ionisation energy between chlorine and argon. So as we go from left to right across the periodic table, so from chlorine to argon, yeah, you need to put 3 points for this. So the difference between chlorine and argon is that the proton number increases. Sorry about my writing with this pen again. The proton number increases, but electrons are being added to the same shell, so they're experiencing same shielding, experiencing the same shielding. But that's not affecting the atomic, the ionisation energy, but because the proton number is increasing, the shielding is staying the same, they have a greater nuclear attraction between the outer shell electron and the nucleus. You need to put all 3 points, 1, 2, 3, to get those 3 marks. Okay, to the next. So explain why there is a decrease in first ionisation energy between argon and potassium. Now, if you notice, argon is higher up in the periodic table than potassium, so we're going from argon down potassium. Okay. So this is just pretty much the opposite to the other one. So here, as we're going down that periodic table, there are more shells. Okay, got more shells is more electron shielding, therefore less nuclear attraction between the outer shell electron and the nucleus, because you've got those more electron shells. And that's all you needed to put for that question, and that's the end of question number 3. So you've got 1 mark there, 1 mark there, 1 mark there, 4 3 marks. Question number 4. The group 2 element strontium was first isolated by Sir Humphrey Davy in 1808. Strontium has a giant metallic structure and a melting point of 769 degrees C. Describe with the aid of a labelled diagram the structure and bonding in strontium and explain why strontium has a high melting point. Include the correct charges on the metal particles on your diagram and appropriate technical terms spelled correctly. So the key here is group 2. Okay, group 2, they're telling you it's group 2. Label diagram. Okay, label diagram and then explain key terms. So it's group 2. You know it's metallic bonding. Strontium is a metal. It's got to be metallic bonding. So it's where you draw your layers with your electrons in between. But a lot of you just put plus. It's not just plus, it's 2 plus. It's a group 2 metal. It loses 2 electrons. Okay, group 2. Got to have all these labelled as group 2, not just plus, group 2, 2 plus. Labelled. Yeah, if you didn't label it, you can't get the marks. Okay. And the last point is that it's strong electrostatic attraction between the positive metal ion and the localized electron. Okay, where you get your 3 marks from, you get a mark for a correct labelled diagram with your right charges in your metals, a mark for seeing the localized electron, and a mark for strong electrostatic attraction. Chemists react strontium with water. Formula, a solution is formed which conducts electricity. Write an equation for the reaction of strontium with water, including state symbols. So strontium, formula for that is, the formula for strontium is Sr. And it tells you it's reacting with water. Okay, it doesn't give you any more indication of what you get, but it tells you that the solution conducts electricity. Now, if you're reacting strontium with water, you're going to get strontium hydroxide. Now, remember, strontium is a group 2, and hydroxide is a minus charge, so you've got to have 2 of these to every 1 in your strontium. And you're also going to get hydrogen given off. You need state symbols. Strontium is a metal, so it's a solid. Water is a liquid. Conducts electricity, it's got to be aqueous, and hydrogen's a gas. Now, this isn't balanced yet. So the strontium is balanced. Your hydrogens aren't. You've only got 2 here where you've got 4 on this side, so we need 2 on this side. How many oxygens? We've got 2 on this side, 2 on this side, so it's now balanced. So you would get a mark for the correct balanced equation and a mark for your state symbols. Okay? Now, a hydroxide predictifies the pH, excuse me, of the resulting solution. So this is a hydroxide. As long as you put value anywhere between 8 and 14, you get a mark for that. And give the formula for the negative ion responsible for the conductivity solution formed, OH minus, for a mark. Heartburn is a form of indigestion caused by an excess of stomach acid, stated compound of magnesium that can be used to treat heartburn. So you can have magnesium hydroxide for this. A lot of you got it right, but didn't put the right formula. If you're not sure of the formula, write the name. Okay, magnesium hydroxide, magnesium oxide, or magnesium carbonate. You could have any of them for a mark. But again, if you're not sure of the formulas, write it out, okay? Write out magnesium hydroxide, because you could lose marks for doing the incorrect formula. So question 4, part D. Group 2 elements also react with dilute hydrochloric acid. Describe and explain the trending reactivity of group 2 elements with dilute hydrochloric acid as the group descends when you're going down the group. In your answer, you should use appropriate technical terms spelled correctly. So this is just an ESPNAI question. Electron shell shielding, proton number, nuclear attraction, atomic radius, ionization energy. As long as you've covered those points in your question, you are going to get the marks. Again, look at that F321 exam technique booklet. It's all outlined for you there. So group 2 elements, as you go down the group, first point, you need to talk about the reactivity. Reactivity increases as you go down group 2. This is because as we go down, the atomic radius increases. The atomic radius is increasing. Electron shielding increases. And you notice how in the bullet pointing it, all they're bothered about here is your spelling. Just bullet point it. Make sure you get everything you need to included into this answer. Okay, we're talking about electron shielding is increases, and because of this, those outer shell electrons are further away from that nucleus. Even though that proton number is increasing, it doesn't matter. So that nuclear attraction, the outer shell electron is decreasing. Yeah, nuclear attraction, the outer shell electron is decreasing. Therefore, ionization energy must also be decreasing. It's got to be easier to remove that outer shell electron if reactivity is increasing. Yeah, as you go down the group. No, that's to do with group 2. Okay, so your marks, literally 5 marks with 5 bullet points. Okay, and lots of people were writing massive long essays and contradicting yourselves. Be very careful with this. Bullet point your answers. All the bothered about here was that ionization energy was spelled correctly, nuclear, and possibly shielding. Okay, as long as you're spelling those key terms correctly, you will get the marks. And that's the end of question 4. So question number 5. Ammonia, NH3, and hydrazine, N2H4 are both bases. Ammonium phosphate can be prepared by reacting ammonia with phosphoric acid. Why can ammonium phosphate be described as a salt? Because the H plus ions have been replaced with ammonium in this case, okay, or a positive, not metal ion, sorry, or a positive ion. As long as you wrote anything along those lines, you will get those marks, okay? That's just another definition that you need to learn. For part 2, the student was given 400 centimetre cubed of aqueous ammonia solution. The student was asked to determine how many moles of ammonia was dissolved to prepare the solution. The student titrated 25 centimetre cubed of ammonia and found that it reacted with exactly 37.5 centimetre cubed of a 0.1 mole per decimetre cubed of phosphoric acid. Calculate the amount of moles of NH3 in the original 400 centimetre cube solution. So the first thing that should shout out to you is that you've got concentration and volume of something. If you've got concentration and volume, N equals C times V over 1,000 in this case because it's in centimetre cube, calculate moles, okay? So phosphoric acid, moles, equals 37.5 times 0.1 over 1,000. That gives you 3.75 times 10 to the minus 3 moles of phosphoric acid. Okay. And if you look at your molar ratio, it's asking now, it's all talking about ammonia. If you look here, you've got 1 and 3. So you need to times this answer here by 3, which gives you 0.01125 mole of ammonia. Okay, but that's in 25 centimetre cubed. Okay, what they want to know is the amount of moles in the original 400 centimetre cube solution. So what you need to do is your answer times what you want, which is 400 centimetre cube, over what you don't want. Yeah, what you want over what you don't want. And by my calculator, that gives me 2.8 mole of ammonia. But remember, even if you didn't know how to work this out, you can get 1 mark for simply just doing your C times V. Okay? You get 1 mark just for doing that. Even if you do not know where to go from there, just get that wrote down. Okay? Don't let all this put you off, just do one of these at least. You get 1 mark for calculating the moles of phosphoric acid, a mark for using your molar ratio. Okay, getting that answer there, and then taking into consideration your volumes to get the final answer. So 5 part B. The hydrazine molecule is a covalent compound. Predict the NH2 bond angle in a hydrazine molecule. Explain your answer. This is worth 4 marks. Over here I've drawn hydrazine. Sorry for the poor quality. Okay, but remember nitrogen's got 5 electrons in its outer shell and hydrogen's got 1. So this is hydrazine. But what it's interested in is just one, the NH2 bond angles. Okay, if you notice, every nitrogen has got 1, 2, 3 bonding pairs and 1 lone pair. Okay, you've got 3 bonding pairs and 1 lone pairs. That gives you a bond angle of 107 degrees. That should be shouting pyramidal to you, 107 degrees, okay? And then you just need to write lone pairs repel more than bonding pairs repel equally. Okay. Best thing to do is to draw it out. Okay, if you can't see this just by imagining this molecule, draw it out. Draw it out and you can see then. You get a mark for saying that there's 3 bonding pairs among lone pair, 107 degrees, lone pairs repel more than bonding pairs, and bonding pairs repel equally. Nice, easy 4 marks there. So part C, hydrazine, N2H4 is found used as a rocket fuel. Right, they're giving you an equation and they want you to do oxidation numbers to explain why the above equation represents a redox reaction. Okay, so remember oil rig. First of all, oxidation is loss, reduction is gain. And then under my base hope, it's chin. Uncombined element combined with itself is 0. Metals have the oxidation state of whatever group they're in. Chlorine -1, hydrogen usually +1, oxygen usually -2, chlorine usually -1. Okay, so we've got +1 3 times, that's going to be -3. Remember, potassium root 1, oxygen -2. So this chlorine's got to be +1. Here, +1 4 times, so that's going to be +2. Here, -1, +1. Oxygen -2, hydrogen +1. So now have a look and see what's changed. So what's changed? Nitrogen here is -3. And it's gone to, sorry, -2 over here. Yeah, it's gone to -2, not +2. My mistake. -2. Yeah, careful of that. See, even I made a mistake then. Make sure you correct and let you go. And of course, you've got -3 going to -2. So nitrogen, first of all, right here, -3 to -2. What else has changed? Hydrogen's not changed. Chlorine +1, -1. So chlorine's the other one that's changed. Chlorine has gone from +1 to -1. Okay. So you've now used oxidation numbers. You're automatically getting a mark there. Okay. But what you now need to write is which one's reduction and which one's oxidation. So here, chlorine has gone from +1 to -1. It's reducing in numbers. It's reduction. It's gain in electrons. So here, there's got to be oxidation. Okay, and you've got a mark for the oxidation numbers being correct. Mark for stating that oxidation and mark for stating that's reduction. Okay, you need to state the numbers. If you've not wrote them there, make sure you write them here at least. Okay. So what is the system name for KClO? And this is potassium chlorate. Okay, you can put that to get the mark. A lot of people wrote bleach. ClO minus is bleach, but this is asking about the systematic names. You have to say potassium chlorate. Anything with ClO minus has got to be a chlorate. Okay. Last but not least, the overall reaction takes place in 2 stages. But NH2Cl is produced, and in the second stage, N2H4 is produced. Some of the hydrazine reacts with NH2Cl to form ammonium chloride and a colourless gas with a relative molecular mass of 28. Construct an equation for this reaction. So it's telling you that hydrazine is reacting. So you know what the formula for hydrazine is. N2H4. Okay. N2H4 is the hydrazine. It's reacting with NH2Cl. Telling you it forms ammonium chloride, NH4Cl, and a gas with a relative molecular mass of 28. Now, gas has got to be 2 elements combined, so you can't just go to your periodic table and pick something with 28 on it. You've got to have a look, and the only thing, if you times it by 2 to get 28, it's got to be nitrogen. Okay, so it's got to be N2. And then the last thing we had to do was balance this equation. So on this side here, we've got 2, 3 nitrogens. This side we've got 3 nitrogens, so that's fine. 4, 5, 6 on this side, but we've only got 4 on this side. Cl here we've got 1, Cl here we've got 1. So the easiest thing to do is to get your nitrogens into 8. So the first thing for you, not your nitrogen, so your hydrogens into 8. So here 2 times 4 is 8. Here we've got 4, 5, 6. So again, here we've got 8 now. So let's check everything else still balances. 2, 4, 2, 4. Yeah, and that's it. You don't need to put state symbols in this case. So what we're looking for is correct equation, balanced, and the identification of this being correct, N2 being correct, B2 marked. And that's the end of the paper.